Hello and welcome to this introductory video on current and Ohm's law. In this video we're going to take a quick look at what is current and then we're going to go ahead and start talking about resistors, and in particular a subset of resistors called ohmic resistors that actually obey a nice relationship called Ohm's law. And we'll introduce all of those aspects. So let's set the stage. Suppose that what I'm going to do, because we've been talking a lot about capacitors in the recent videos, let's stick with that theme. So suppose I've got my capacitor and it is charged, and so I've got a bunch of positive charges over here. So I've got a positive potential V there and a potential of 0 on the opposite plate. Suppose that I actually took something and connected those. So if I connect those, what's going to happen? Well, assuming that this material is not an insulator and it allows charge to flow at least a little bit, then charge will flow because I've got a potential difference, and positive charges stuck here in the high potential want to move towards lower potential. Put another way, we know that they're exerting forces, they want to repel each other, and now by bridging this, they're free to, and so some positive charges will flow across here. That flow of charges is a current. So we denote current by the symbol of I, and it is quite literally a flow of charges. And we talk about it basically as sort of a speed of charges. So we talk about the charge per unit time that flows across here. So some charge Q goes through there. So in terms of units, that's just a coulomb per second. And we give that thing a name, which is an ampere. Okay. Now, as I say, some materials are really good. Wires, for instance, conduct very nicely. The charges move almost freely across. Some other things which still conduct offer more resistance. So we can introduce this idea of trying to talk about how much this wire wants to resist the flow of current by its resistance R. And we're just going to say that that thing is some quantity, and we'll look at that in a subsequent video, that describes just a bit of how easily things flow. And so when that value is higher, that's going to mean more resisting the flow. And if it's lower, then the flow is much freer. So we've got resistance. That thing has a special unit. We call it ohms. It has the symbol omega. But the important part about this is we've now introduced that we know that the current is going to have to be proportional to 1 on R. Okay. Because basically, as we've just said, as R increases, it means you're more and more resistive to allowing the flow of current. So that's described by this relationship here. Now we can also think about this a little bit more. We also know that if I make the potential difference larger, then there's more energy, and more energy means that I can more readily overcome whatever resistance is in this wire. So I also know that I could write something like I should be proportional to V. And if we then combine I being proportional to V with I being proportional to 1 on R, we know that we can write it as proportional to V on R. And for a special class of resistors called ohmic resistors, the constant of proportionality there is 1. And so we have Ohm's law that I is just V on R, or rewritten V equals IR. So that's it. That is Ohm's law.